I hope everyone's having a great day because in this video we're going to be learning to graph a basic rational function. I am Mr. Ish. Thank you for joining me. You know, a rational function will have a numerator expression and a denominator expression, and how would you go about doing that, especially when you know with these type of expressions an asymptote or more than one asymptote will develop. We can start here with something which is not too hard, and let's show you. We'll have something like this: 2 and 5 minus x. You know you have 2 in the numerator, 5 minus x in the denominator. When you want to graph this out, the first step you want to do is look for the 0 of your function, and the 0 of the function will be determined from the denominator. You have 5 minus x is equal to 0, minus x is equal to minus 5, and x is equal to 5. You solve for this x right here in the denominator. This right here will tell you what your vertical asymptote is, and it's 5. X equals 5. You can start with the graph and then you can actually plot this out. X equals 5 is your vertical asymptote. That right there is your step number 1. Step number 2, determine if there's a horizontal asymptote or not. You can determine the horizontal asymptote by looking at the numerator and the denominator. When you're looking at the numerator, you want to be looking at something called the n, and in the denominator, you want to look at something called the m. N and m. N represents the highest order or degree of exponent of that variable in the numerator. In the numerator, you don't see a variable, but technically you do. It's 2x to the power of 0. Therefore, your n value here in the numerator is a 0. In the denominator, you see 5 minus x to the power of 1. Here your m value here is 1. When the n value, the highest order degree of the exponent of the variable in the numerator, is less than that of that for the denominator variable, the order of the exponent of the denominator variable, then you have a standard horizontal asymptote of y equals 0. That's just the way it is. You have the standard asymptote y equals 0, and you know y equals 0 represents your x-axis. So for this particular question over here, your x-axis is your asymptote, horizontal asymptote. We have y equals 0, we have x equals 5. Two asymptotes. There will be no oblique asymptote, anything which would cut across, because for an oblique asymptote you must have n is equal to m plus 1. The degree of the exponent on that variable in the numerator must be 1 more than that for the denominator, but here you already know the denominator has the highest order degree in terms of exponent. So the oblique asymptote is totally out of the picture. Step number 3, see if the origin is involved in any way. You can do that. Put a x value of 0 in terms of your expression and see what happens. When I put 0 here in place of x, I get 2 over 5. So I know I'm getting a legitimate value here. The origin is not involved, but you're getting a good y-intercept at 0, 2 or 5, and you can estimate it to be like that. Now you know basically something's going to happen. Your cutoff here, these lower parts are cut off, these lower quadrants are cut off by this asymptote here, horizontal. Therefore you must have a graph which must go up in this direction, and on this side you must have a graph which comes right over here, and that right there would complete your graph for this. It would be exactly as you're seeing it. You can test these values out. If x right here was equal to minus 10, and then you plug right over here into your expression, you'd have 2 over 5 minus minus 10, you'd have 2 over 15, which is a positive value. At an x value of a minus 10, you're having a positive y, so you know your points here would be good. You can test it out here again for a value right on this side. If x were equal to 10, because here x is equal to 5, pick a value 10 over there. Plug 10 over here, you'd have 2 over 5 minus 10, and you're having 2 over minus 5, so you know in terms of y value you're here in the negative, so you're good. This graph here is good. If you had accidentally drawn the graph like this and then like that, you would be wrong. There are two things here which clued you into exactly where the curves are. One is right here, this part right here. Was the origin involved? No, it wasn't, but it gave you a y-intercept, which was this. Then the other one were these two test values you took. With one negative x value, which was a test value, you got a positive output. With a positive x value, you got a negative output. So you know your curves are exactly as you see them. So this question here is completed. Now we look at this question over here. And this will be the second, but we'll keep this as our last question for this video. We're looking at basic rational functions, how you graph them. Step number 1, determine the 0 of this function. The 0 of the function is always determined here from the denominator. You make it equal to 0 and you solve for x. Minus x is equal to minus 1, x is equal to 1. This here tells you you have a vertical asymptote. which is right here, x equals 1, you can start graphing it out and just put your vertical asymptote right here, x is equal to 1. When you're looking at this, again, step number 2 for your horizontal asymptote, you look at the n and the m. The n represents the highest order degree in terms of the exponent for the variable in the numerator. You're seeing here x to the power of 1, so you know n is equal to 1. And m represents the highest order degree of exponent for that variable in the denominator polynomial, and you're seeing here to the power of 1, you're seeing here 1. This is not a situation where n is equal to m plus 1, so there is no oblique asymptote. You don't need to worry about oblique asymptotes unless you're going to be looking at more complex rational functions. Either in our instances n is going to equal to m, or n will be less than m. You know, in the previous example n was less than m, so you have the horizontal asymptote being your x-axis, your standard horizontal asymptote, y equals 0. But we don't have that here. Here we have a situation where n is equal to m, so now you have to determine what exactly is that horizontal asymptote. It's not the x-axis anymore, and there's a technique for doing it. You take your numerator expression, you divide it by the highest variable degree that you see in the entire rational function. I'm seeing in all instances here x to the power of 1. There's x to the power of 1, x to the 1. You take your numerator and your denominator expressions and you divide them by that highest order degree of that variable. You see x plus 2 divided by x and 1 minus x divided by x. You see I'm dividing it by the highest order, and now you manipulate this. You do x over x plus 2 over x. This is the numerator being separated into its own separate fractions, and then 1 over x minus x over x. Simplify. X over x is equal to a 1, and then you have this 2 over x, and then you have 1 over x minus 1. Then you do a certain limit as x approaches infinity. Wherever you have x, you put infinity over here. I would do a 2 over infinity here. I would do 1 over infinity. 2 divided by increasingly large numbers zeros out, it becomes a 0. 1 divided by an infinity is like 1 divided by an extremely large number. Its value is so small in terms of fraction, it zeros out. So technically I have 1 over minus 1 and I have minus 1. That tells me my horizontal asymptote here is y is equal to minus 1 by means of this procedure. This procedure comes out in those instances where n is equal to m. So you have to do this elaborate procedure. Step number 3, see if the origin is involved or what happens at the value where x is equal to 0. You put 0 here in place of your x values. You'll have a 0 plus 2 over 1 minus 0. You'll have a 2 in terms of your output. So you know you have 0 comma 2 y-intercept. Y equals minus 1. I didn't mark that out, so let me mark that out. That was y equals minus 1, my horizontal asymptote. But I know based on this 0 comma 2 is a value which is involved right over here. Now I have to determine the curve. You know the curve is very much going to be something like this. You're seeing it develop, and then the curve like this. But you have to test it out. Let's pick a value over here. You know you have a value here, x equals 1, so let's pick a value at x equals 5. What would happen if x were equal to 5? We put it in here, 5 plus 2 over 1 minus 5. That gives me a 7 over a minus 4. I'm getting a negative output, which would be larger than a minus 1, right? This is larger than a minus 1. This is more like minus 1, 3 over 4, and it passes this horizontal asymptote y equals minus 1, and you'd have a value coming right over here, right over here. And this tells you that this curve here is right. You can check to see if this curve is right as well. Just pick a value like right over here. If x were equal to minus 1, what would happen? We did this test value, we did this test value, put it in here, minus 1 plus 2 over 1 minus minus 1. What are you getting? You're getting here a 1 over 2. So at a value of minus 1, you're getting like a half. So you're good. You're here in a positive value. So these curves are good. So that tells you that your rational function curve here is good. Remember, when you're given a basic rational function, determine initially what your 0 of your function is. That 0 of the function will help you determine your vertical asymptote. Then the next step, determine your horizontal asymptote by comparing the n and the m values. If n is less than m, your x-axis is your standard horizontal asymptote. If n is equal to m, you have to do that specific procedure I showed you. Divide the numerator expression, the denominator expression separately by the highest order degree of variable and see what happens as you do that limit x approaching infinity. Whatever you get at the end of that right there is your horizontal asymptote. Step number 3, determine if the origin is involved. Sometimes it is. If you put x equals 0, you'll have a y equals 0 and your curve will go to the origin. But if it is not involved, at least you'll get a y-intercept. And then from there you can get an idea of your graph. and then do some test values to see if you've mapped the curves on the right side of the quadrant. And it's pretty much this procedure right over here. And that's it for this video. Thank you for watching. Have a good day. Bye.